Hi, today we're going to look at transformations of functions. A transformation of a function is when you take a function's graph and you do something to it like moving it around in the plane or stretching it out or compressing it or something like that. So what I want to look at is these three types of transformations: shifting, reflecting, and stretching and compressing. Now of the three, shifting is the easiest. So let's start with just some shifting. Let's start with the function that we know, x squared. We've got a nice parabola here. If we wanted to shift this parabola up, what we would do is add a number onto it, like say plus 3 or plus 2, like that. If we wanted to shift it down, we'd subtract something from it. And if we wanted to make it where we could slide it around the plane, I'm going to put a plus c on there. And now I can move the slider around and slide the thing up and down. Now it makes good sense that by adding a number it goes up, and by subtracting a number it goes down. But what if we want to shift it side to side? Well, first notice when we're shifting it up, we're adding 1 onto it. If you look at what's going on, the value for y, we take x squared and then we add 1 onto it. So adding 1, that bumps y up by 1. If we want to move it side to side, we would add a number onto x, like this. Notice x plus 1, the plus moves it over to the left. Now the way I tell people to remember that is plus and left both have 4 letters in it. Also, minus and right have 5 letters in them. But you might look at this and say it's kind of counterintuitive that a plus would move it backward. But if you think about what's going on here, you pick some value of x. In this case, let's say you pick -1. Before you square it, you add 1 to it. So it does shift things over to the well, it winds up shifting the graph itself to the left. So if we wanted to combine this together, I could give a number there, and a number here, add these sliders, and then I could move this around and slide it side to side, up and down. Woohoo! And basically move the parabola around anywhere I want it. So let's look at a couple of other problems here. Let's say we want to figure out what this graph is. Well, the base graph here is absolute value of x. I know that because of the V shape. And so if I wanted to take this green graph and transform it into the black one, what I would need to do is move it down 1, 2, 3, 4 units. So I'm going to put a -4 there. And then it needs to move to the left 2 units. So I need to put a -2 here. Wait. It needs to move to the left. Yeah, it needs to move to the left 2 units. So left and plus both have 4 letters in them. So get a +2 there. All right, let's look at another graph. Let's look at this. Okay, this is a parabola. And if we look at it, let's zoom in a little. Looks like we need to go down 1 unit. And then to get it at the right position, left versus right, we need to move from 0 to 1.5. So Which direction are we moving there? We're moving to the right. So I need to put a minus 1.5. There we go. Now, let's look at, that's pretty much all there is to shifting. But let's look at reflecting. So I've got x squared here. And if I wanted to reflect it upside down, I just put a negative on the front. Notice the negative here, if you think of order of operations, for some value of x, you square it and then you take the negative. It makes all of its output numbers negative. If we put the negative inside of here before the square, whatever the number is, we take its negative and then we square it. Well, since it's a square, it doesn't really change the look of this at all. So I'll tell you what let's do. Instead of square, let's look at x cubed. If I put a negative on the front of that, it flips the graph upside down. If I put a negative just inside of here with the x, it's going to flip it horizontally. In other words, it's going to reflect it across the y-axis. However, thanks to the symmetry, we can't really see much there. So I'll tell you what let's do. Let's make up a more complicated function. X cubed plus x squared. Better yet, let's do this. X times x plus 3 times x minus 1. This graph right here. If I wanted to flip it upside down, all I have to do is negate the whole thing. Flips it upside down. If I wanted to flip it horizontally, then I would need to negate each one of these x's individually. And if you look at that, those two graphs are mirror images of each other. So I had to do that to each individual x. Another way of saying this is, I could call this f of x equals that thing. And if I graph y equals negative f of x, that flips it vertically. If I call it f of negative x, that flips it horizontally. So let's look at a few other things here. Let's say that we wanted to find this graph. Now, when you start combining reflections or flips together with shifts, you can get sometimes it can be a little difficult because the order in which you do things matters. So here's how I would do this graph. If I'm trying to figure out where is, what's the formula for this? This is a square root graph. If you look at it, just by looking at the vertex, I'll call it here at 0, 0, we need to shift it over to 1/2, 3. So it needs to go right 1/2 and up 3. So that's got our vertex at the right point, but we also need to flip the thing upside down. Now, if I just come over here and put a negative on the front, that'll do it. Sometimes things are a little more complicated than that, though. Let's look at this graph. I'm going to change the color of it. So this red graph. And I want to come up with the equation for that. I know it's going to be square root of x. And there are a couple of things going on here. I've got to shift it, let's see, it needs to shift from 0, 0 up to 4, 3. So 3 there, and then minus 4 there, and that gets us to the right spot. But we still got to reflect it. Now, if I just put a negative here on my x, notice what that does, it reflects the whole graph across the line, across the y-axis. So instead of just taking it and spinning it around where we want it to spin, it reflects it all the way across. So what I really need to do here is put this inside of there. So I could put the negative and then x minus 4, or I could just make it minus x plus 4, and that does it as well. So you have to be a little bit careful with this. What I would advise you to do if you're doing this type of problem is to check it with Desmos as you're doing it. Let's do one more. Okay, this graph. I think we've already done that one. All right, let's stop looking at reflections and shifts. Let's look at stretching and compressing. Actually, let's save that for the next video.